Good morning everyone, I'm Dana Mahmoud from 12G1 and today I'll be presenting about nitroglycerin explosions. Nitroglycerin, also known as nitroglycerin, is a dense, colorless, oily, explosive liquid most commonly produced by nitrating glycerol with white fumic nitric acid under conditions appropriate to the formation of the nitric acid ester. Chemically, this substance is an organic nitrate compound rather than a nitro compound, but the traditional or common name is retained. And as you can see below, this is the structure of nitroglycerin, followed by its molecular formula. In 1847, an Italian chemist called Ascanio Sobrero tasted a small amount of nitroglycerin and found that it tasted sweet. But after that, he experienced a violent headache that lasted for many hours later. He also discovered how glycerol reacts with fumic nitric acid. So, in the reaction below, we can see glycerol with 3 molecules of nitric acid reacting to produce nitroglycerin and 3 molecules of water. A lot of people tried to make nitroglycerin safer and more stable since it wasn't stable at all. And the mining industry and military seized on nitroglycerin as an alternative gunpowder. So in one day, a Swedish scientist called Alfred Nobel accidentally dropped some nitroglycerin. He expected it to explode and immediately kill him, but the nitroglycerin dropped on a sawdust, and the sawdust contained a clay-like dirt called diatomaceous earth. So he invented dynamite by packing nitroglycerin with the diatomaceous earth powder. So let's take a look at the dynamite structure. A is the mixture of sawdust and the diatomaceous earth powder. B is the protective coat. D is the electric cable or the fuse in which people set it with fire to make the dynamite explode. And C is the preload. Now that we're familiar with nitroglycerin and we know that it's explosive, it's time to know the reasons behind its explosivity. So first of all, nitroglycerin contains both oxidant and fuel, the only 2 substances needed in order for an oxidation reaction or a combustion reaction to occur. Nitroglycerin molecules contain 3 nitrate groups and they act as powerful oxidizing agents, bound directly to a hydrocarbon fragment which acts as a fuel, so they don't really need oxygen in order to continue the reaction. Secondly, a large volume of gas is produced when nitroglycerin detonates. Nitroglycerin has a density of 1.6 grams per milliliters in room temperature. 4 moles of nitroglycerin occupy about 570 ml. The gas produced by detonation of this amount of nitroglycerin would have a volume of about 710 liters at room temperature. The actual volume would be much higher if the temperature rise accompanying the reaction considered. There is also another use of nitroglycerin, other than explosive, and that is medical use. Around the same time that Nobel was inventing dynamite, scientists and some doctors started noticing the effects of nitrate compounds on the heart and experimented them by using them to treat chest pain. So scientists made nitroglycerin as pills and sprays. But wait, is that safe, or will medicines explode by any chance? Fortunately, no. Scientists have made nitroglycerin pills safe enough by putting a very low amount of nitroglycerin and diluting it with inert materials, which are materials that cannot be recycled. So how can we make nitroglycerin in the lab? You will need glycerol, nitric acid, sulfuric acid, sodium bicarbonate, and ice bucket. Step 1. Take 10 ml of fumic sulfuric acid and pour it in a measuring cup. Then place this cup in the ice bucket till the temperature reaches to 10 degrees Celsius. Make sure the temperature remains constant. Now you will add few drops of glycerin and keep it there for about 13 minutes. After 13 minutes, carefully transfer the entire mixture into another beaker containing cold water. You will notice a white paste settling down at the bottom of the beaker. This is nitroglycerin. Filter it and add sodium bicarbonates, and now remove the nitroglycerin from the sodium, and you're all done. And before I end my presentation, I would like to show you a short video that shows how nitroglycerin explodes.
And we're only going to use the tiniest amount to show them.
Sobrero wrote that the safest way to demonstrate these properties was to dip a hot wire into a glass bowl of the substance. But he was scarred for life by flying glass, so we are going to try something different.
Even slowed down more than 500 times. The explosion is incredibly fast.
That's a bit of a kick. Now, the reason why that's so sharp is because if you look there, every single molecule of that liquid has disappeared. It's turned almost instantaneously into gas, hence the nice explosion.
Thank you so much for listening, and I hope you enjoyed my presentation and learned something new from it. Have a good day.